there's not a whole lot of room to account for that, because when we're cruising and we got a mission to do, we're cruising. We're not lollygagging around. We're staying full speed.
Yeah.
And based upon the distance, and I've mapped it out before, from like, the East Coast of the United States over to like, the Mediterranean, and it should have took a certain amount of time, and it ended up taking, less time than that. And I'm like, how is that possible? Because we don't go faster than that.
And when you say less time, you mean by days or
by
hours?
days?
By days.
By days.
What?
So you're supposed to be there on Friday and you show up on a Tuesday type of thing?
Well, not that crazy, but like,
bad.
but bad. It's quite a bit off. And, I've been on deployments before where, we have a max speed and we can't break that speed by limitation. And we've gotten there earlier. And I'm like, so I've made this trip before going across the pond, the Atlantic Ocean.
Yeah.
And it took us like 2 weeks.
Yeah.
As where I've went across it before and it took us like, a week and like 5 days.
Whoa. Wait a minute. Wait a minute. Because now we're getting into something that's bordering on Jonathan's area of expertise, which is you're saying that okay, so the first time when we'll just throw out examples because I know you're not going to give out, we don't even know what ship we're talking about, so it doesn't really matter. But if you're crossing the Atlantic and you're doing, let's say, max speed because you're on mission, you do it in 2 weeks, but all of a sudden the next time you do it 2 days ahead of schedule, even though physically you shouldn't be able to exceed that speed.
Yes.
Wow.
I have had that happen before, and I never thought about it, in this light, because I got off that ship back in 2012.
Yeah.
But looking back on it, we've had plenty of times that's happened, especially I've been down to South America. I've been across the equator, quote unquote.
Yeah.
And circumnavigation, when we go down that far, seems to take a lot longer of a time for us to travel to point A to point B, and it doesn't add up.
Let's get back to this though, because you mentioned something that we haven't touched on yet, which is you were saying that when you're south of the equator, you ran into things that kind of fit in with the models that we've been discussing for the last 6-7 months, which is distances seem to be out of whack when you get well, on a globe it's south of the equator, but on a flat map it's out in the outer ring. Is that something you can you elaborate on that?
It's something that actually makes perfect sense to me, because it actually took longer a lot of times to get to an area whenever we are tracking and making sure that we're on a proper course to get to a certain area like Costa Rica or Guyana or Suriname or something like that. It took a lot longer to get there than what I thought it was going to, because they said, oh yeah, we go such and such fast, and I'm like, I've looked this up in retrospect, like how long it's actually plotted to be, and it should have taken like about 3 or 4 days less than what it actually took.
Oh, I got you.
Like, yeah. So it was much longer.
Just keep an eye on what it does. Right, I'll just do it with a normal one line. Okay, straight over the North Pole. Here's the North Pole. We're going straight over the North Pole, as they said. Okay, we want to go to Sydney. Well, but it's going to do that though, you see. It's going to swing it round like that. But look, 10,468 miles. But look at what it's done. It hasn't let me go straight over the North Pole. So we'll change that to clear that. I've changed that to path, so then I can plot the route more manually, but it's not going to make any difference. Okay, here's the UK. That's what I'm doing now. Straight over the North Pole, so we'll have to plot lines. Okay, straight over the North Pole. We want to go to Sydney, so we're going to have to be going over this way a bit. Sydney. Okay, it's a little bit more, 11,000, but it doesn't matter, because look, according to them, you can go straight over the North Pole and cut 8 hours off the journey, but the distance is the same. There is no shortcut on the globe. Okay, here's our flat map. Okay, there's the UK, there's Europe. I've flown this route a couple of times. They take you across Europe, and then you stop over. It can be Singapore, Thailand, any of those places, and then you go to Sydney. But they're saying, oh, you can just go straight across there, and it'll knock 8 hours off the journey. There's a reason why. Because it's flat. It's a shortcut on a flat Earth. Okay? That's the original route, and that's what they're saying that they can do if you go straight over the North Pole. That can shave off 6 to 8 hours off a flight from here to here just by simply taking a shortcut across here. It's not possible. Get your globe and try and plot these destinations yourself. Okay, they'll always be the same, whichever direction you're going. Okay, UK, come on. UK, across Europe. Okay, stop over in Bangkok to Sydney. It's around about there, isn't it? Which is correct, about 10,400 miles. But again, if you do what they're saying you can knock 8 hours off that journey by just simply going over the North Pole. Well, that's the North Pole. And it's going to redirect there anyway. So the only way I can do it is to do a manual path. Okay, do a manual path. Come on. Okay, to set a manual path. Okay, it's saying 11,400, but obviously you would fly a bit more straight at this here, but it doesn't matter. It's still going to be the same distance. It'll still be roughly 10,400, 10,600 miles, whichever direction you go. So how can they say this? How can they say airlines given permission to fly over North Pole for the first time, slashing the hours to exotic destinations up to 50%? Whole new world opened up, says Branson. They haven't done this as far as I know. This is from 2011. Many long-haul flights times will be dramatically reduced as planes are allowed to take a shortcut over the North Pole.
All other proofs aside, the differences between the globe and the flat Earth become apparent when considering distances south of the equator. After all, haven't navigators, geographers, and map makers mapped these areas? And shouldn't they have noticed this quirk by now, if the Earth is indeed flat? Well, the reality is, the rabbit hole just gets deeper from here. So, to begin, the distance between Sydney, Australia and Nelson, New Zealand, on the ball Earth, given their coordinates and sparing you the spherical trigonometry, should be 1,310 miles. But the Australian Handbook, Almanac Shippers and Importers Directory, states the measured distance as being 1,550 miles, which is a full 18% longer. And while on the ball Earth model, Antarctica is said to be a continent of ice situated at the bottom of the ball from 78 degrees south latitude, it should therefore not have a perimeter greater than 12,000 miles. However, early explorers like Captain Cook and James Clark Ross, in attempting to circumnavigate Antarctica, took 3 to 4 years to do so, and clocked in the distance traveled at 50 to 60,000 miles. That's twice the circumference of the equator. But the real proof for the flat Earth map is in the flight paths. On the ball Earth, several flights would have their shortest, quickest, and straightest path over or around the Antarctic continent. But instead, these flights take all manner of tangential detours, crossing into the northern hemisphere to refuel. Their reason? Antarctica's too cold, they claim. Well, I'm not buying it. When they claim there are bases with working machinery set up all over Antarctica. So let's just take a look at the actual flight paths and see what they have to disclose. One flight that should be a simple 11-hour shot across the Indian Ocean is from Johannesburg, South Africa to Perth, Australia. However, this flight takes a detour north, stopping in either Dubai, Hong Kong, or Malaysia to refuel, for a total flight time averaging over 18 hours. This ridiculously wayward detour is frustrating to say the least, but on the flat Earth map starts to make sense. Another quick and easy flight, you would think, is from Johannesburg to Santiago, Chile. While an easy 12-hour flight below the Tropic of Capricorn is to be expected, instead every flight crosses the equator to refuel in Senegal, all the way near the Tropic of Cancer, for a total flight time of 19 hours. Though it doesn't make sense on the globe, as you can see it fits perfectly on the flat Earth map. A third flight from Johannesburg is to São Paulo, Brazil, which should be a direct 10-hour flight across the 25th degree south latitude. But instead, every flight crosses into the north to stop in London to refuel, making the total flight time 24 hours. From Santiago, Chile to Sydney, Australia, a straight 15-hour flight across the South Pacific is expected, despite refueling options in either New Zealand or any island in the South Pacific. The flight stops all the way at Los Angeles to refuel before continuing south to its destination. As already stated, these detours make no sense on the globe, but are explained and work perfectly well on the flat Earth map, having the North Pole at the center. So investigate the subject for yourself and ask questions.
Yeah. Well, that could be something.
And speaking on the gyroscope thing, I kind of wanted to touch on that really quick. He mentioned it, and I'm pretty sure you remember me talking to you about it yesterday, Mark, off air. But one thing that really nailed the last nail in the coffin for me on this whole globe thing, you know, any flat earther I've met will always admit that we don't know 100% whether the Earth is like, you know, a perfect, you know, disc just floating around, you know. But we do stand on the principle that we know it's not a globe. We won't sit there and say we know 100% it's flat, but we know it's not a globe. And the reason why I say that is because of the laws of precession. A gyroscope, it's considered an extremely accurate instrument we use to maintain attitude throughout space. Mm-hmm. And I'm not talking about outer space. I'm just talking about general space. Mm-hmm. And if anyone's listening, try to conceptualize this for a second. All right, imagine that an aircraft is on top of the North Pole, and its gyro is spun up completely. It's calibrated, it's spun up, and they usually operate them throughout a vacuum. So, no air resistance is going to come across it and try to, knock it off balance. Mm-hmm. So once it's spun up and they take off, they use that as an instrument to maintain level flight and measure the bank of their turns, because the gyroscope has the innate ability to be able to stay always parallel to the flat plane of when they take off. Mm-hmm. Now, if they take off from the North Pole and they start flying down towards the equator, you have to understand something. That gyroscope will stay spinning in the orientation that it was in when it left the North Pole, which if you're looking at the Earth, just if you could zoom out, it would be from left to right, flat line from the North Pole. Mm-hmm. As they fly down around the world to the equator, that gyroscope's going to still stay flat to your perspective, but they're supposedly going down. So it would look on their instruments like their instrument is actually taking a nosedive the entire time. But we don't see that.
Yeah. And that's I'm sorry, Robert, that's also what you see.
Robert. What's that?
I'm sorry, Jason.
I was going to say it's because we're crazy. That's why we don't see it.
No, but Jason, underneath the water, that's the same principle there.
It's the same thing. It's just imagine something spinning so fast. Well, have you guys ever done? You take the front wheel off your bike and you hold it in your hands, and somebody spins it, and you try to move it side to side.
Right. Yeah.
It fights you. Now imagine that spinning at almost 3,000 times per second. Okay, that doesn't move. That thing, it has a reference point, X, Y, and Z axis.
Yeah.
And that ball does not move. Everything moves around. The ship, the submarine, the plane literally moves around it. It stays stationary in all space and time. It does not move. Okay?
Okay.
So that's the zero reference point. So when you're supposed to be going over this curve, it's not registering with this thing that's staying on that x-axis, that plane, that flat plane. It would be reading all that, and it doesn't, because it's not moving. And the front of your plane or ship or submarine isn't pitching down either.
Yep.
So,
wow. And that's the thing. Like, just to piggyback off what he just said, if you apply that to our instruments, and they always train us in the Navy, and I know he knows what I'm talking about, they always train us to trust our instruments. They always say that, trust your instruments, trust your instruments. It's pounded into our head all the time. So if we're to trust our instruments, if they worked on the ideology that, oh yeah, it just, stays flat, but we still somehow just fly around a globe, and, it doesn't change or none of that stuff. If we followed our instruments and it works on a globe model, even though it stays on an X plane, on a flat plane, eventually you would just fly off the world because you're maintaining level flight, right?
Yeah.
Technically speaking, you would be gaining altitude all the time.
And you never do.
Exactly.
Okay, now I want you to pay attention to the way the light follows the sun. The sunlight's going to shrink, right, as it follows the locally illuminating sun. Now watch this. See it shrinking, following the sun? You do not get that if the sun is 93 million miles away. The entire horizon should fade evenly, just like this supposed shot taken from space of the Earth. You can clearly see the way they depict it. They depict the demarcation between day and night, or light and dark, as a long straight line. And you can see the long straight line moving as one solid piece. That means that the sunset should all fade, the entire horizon should fade evenly. But that's not what we observe, as we will see and as we've seen in the footage so far. The sunlight shrinks and follows the sun over the horizon. So these time-lapse sunsets are definitely the nail in the coffin for heliocentrism. But this particular one here, shot from above the clouds from this observatory, is the final nail in the coffin. Look at how the sun just shrinks and the light shrinks to nothing. That cannot happen, as I showed you in the when the sun illuminates the entire Earth, which it does, from 93 million miles away, it has to. You don't get this isolated look at the sunlight trailing the sun.